Abstract. This experiment investigates the conversion of work into heat through operation of a compressor system. The procedure involved initializing the system by turning on the power and fully opening the inlet valve to allow a airflow. And the initial reading of relevant parameters are recorded. The experiment proceeds with the activation of a motor and the adjustment of compressor outlet pressure to specified value. The calibration of a spring balance ensure accuracy measurement of motor force, while the temperature of the outlet air is monitored at 1 minute interval until stability is achieved, indicating the completion of the heat conversion process. The experiment concludes by decreasing the compressor outlet pressure and turning off the system. Through this process, the experiment aims to demonstrate the principle of thermodynamics by illustrating how mechanical works transform into heat energy by using a system of compressor. The objective of this experiment is to observe how heat is converted from work. So basically, we want to learn about how the mechanical work is transformed into thermal energy in the form of heat.
For theory of this experiment is, in a steady state, steady flow system, the mass flow rate of a stream is constant with the time. Therefore, the energy for the system is balanced, which is an open system is equal to the rate of energy transfer by heat, work, and mass, as well as the rate of change in internal energy. In the standard single-stage vent compressor, a fixed volume of air is pushed through two sliding vents and driven by an offset rotor. This fixed volume of air is then pushed out through the outlet with a smaller area. Therefore, its pressure becomes higher due to the smaller area of output. According to the ideal gas law, when the pressure is higher, the temperature will get higher. Therefore, the outlet temperature is increased.
Next, we are moving on to the procedures. Turn on the main switch, then fully open the green valve. Record the temperature and pressure, and also record the temperature for T1 and T2. The left is for T1 and the right is for T2. All the readings are recorded in the table below. When the motor is switched on, the red valve is turned completely and the spring balance is adjusted until the indicator is between the two black lines, both simultaneously. Record P1 and P2, the electrical power, motor spring balance, motor speed, and the flow meter. When the motor is switched on, the temperature T2 is recorded immediately and subsequently at every 60 seconds interval. The reading for the temperature T2 is stopped recording after the last two temperatures is in constant. Now that we have finished with the experiment, it's time to switch off the machine. Turn the red valve back and switch off the motor.
In the experiment, we have obtained a lot of data, which was subsequently plotted on a graph. The first of the graph is the outlet temperature over time. The outlet temperature increases rapidly, then gradually stabilizes at around 455 degrees Celsius. Now we have to calculate and track the energy added to air by the compressor AC and the heat emitted from the compressor QC against time respectively. So, to determine the amount of energy added to the air as well as the heat emitted by the compressor, these equations are use the calculation for HC and QC. As you can see here, HC is the product of mass flow rate, specific heat capacity of air, and the temperature differential. Then you can see the formula of the mass flow rate and the value of velocity, input velocity is from the table. And for QC on the other hand, it is the power of motor subtracted by HC. The formula of the motor power is as shown. Now, we shall see the tabulation of HC and QC with time. Next, these are the graph of HC and QC with time respectively. The graph of HC increases rapidly until it stabilizes at around 661 kW, and while QC decreases rapidly until it gradually stabilizes at around 232 kW. So, HC increases with time and is the opposite of QC, which decreases with time. The relationship of the outlet temperature over time can be determined as time increases. The outlet temperature increases and converges to a constant temperature. At this point, the equilibrium of the graph will reach 0. From the energy curve, we can see that as time increases, more energy is added to the air by the compressor. This happens as the energy supplied to the compressor is transferred towards the air inside the compressor. Okay, we see the second energy graph. Next graph, you can see the heat emitted by the compressor. As time increases, the amount of heat emitted by the compressor decreases over time until it reaches 0. You can see that initially there is a lot more heat energy being produced by the compressor, and as time goes on, most of it is transferred to the air being compressed inside the compressor. For the thermodynamics phenomenon that relates to this heating curve, one of them that which comes to mind is the activity of rubbing two surfaces together very rapidly, such as doing so with a pair of hands. When the hands are rubbed together, heat will be generated by the hands. Over time, the hands will get warmer until it reaches a certain temperature where it will stay at a constant temperature.
For the discussion, which is to explain all the energy conversion that happened during the compressor operation in this experiment, several energy conversion occur. So this conversion highlight the transformation of mechanical work into heat energy. At the beginning, when the power is turned on, the energy is converted to mechanical energy by the motor that can be detected by tachometer reading. After that, the mechanical energy is transferred to the compressor. In the compressor, when the air is compressed, the pressure will increase. The compression of air is adiabatic. Due to the compression of internal energy is increased, that makes the temperature of the air increase. That show the conversion of mechanical energy to thermal energy, which is heat. Because of the work done, the temperature is increased every 1 minute. So which clearly show that the changes of the heat. Throughout the experiment, the principle of the first and the second law of thermodynamics are evident, showcasing the conversion of energy from one form to another form, the increase in entropy resulting from the energy transformation, particularly in the conversion of mechanical work into thermal work, which is heat.
Now, discussion part 3, which is the amount of energy lost as heat as compared to A, the work input to the compressor, and B, the heat added into the air. For A, the amount of energy lost as heat is lower compared to the work input to the compressor. The work input to the compressor was from the power out of the motor and is constant throughout the experiment conducted. For B, the energy lost as heat is also lower as compared to the heat added into the air. In this experiment, energy input was transformed into heat added to air by the compressor. Based on the results obtained, the higher the temperature difference, the higher the energy added into the air. It will also have lower energy loss. This shows that the efficiency of the compressor is higher at higher temperatures.
For discussion number 4, when the compressor outlet pressure 2 is reduced to 0.5, since the pressure and temperature is directly proportional, when the compressor outlet pressure P2 is reduced to 0.5, the value of T2 obtained will be lower than the T2 data obtained when P2 is 1.0 bar. The graph outlet for temperature plotted against the times is less steeper and more flatter compared to the graph obtained in figure 3. The value of HC and QC obtained will also decrease when P2 is reduced to 0.5 bar. In conclusion, the objective of the experiment is obtained, which is to observe how heat is converted into work. Based on the experiment result, the outlet temperature increased exponentially with the time. The energy added to the compressor increased exponentially with time. Meanwhile, the heat emitted from the compressor is decreased exponentially with time. The experiment is conducted that as the single stage compressor heats up, more energy will be added to the air by the compressor, and the heat loss from the compressor will decrease. As time increases, more energy from heat up compressor is used to supply energy to the air in the compressor. As heat energy is unable to fully convert to work, some energy is lost from compressor instead of supplied to the air. Besides, the efficiency of the single-stage compressor increases as its heat. Besides, the efficiency.
When switching off the motor, make sure the students are wearing gloves as the compartments are hot.
Do not put your things near the moving parts of the motor during the experiment.